Ircam to present you some new development on Soundworks. That is a framework that we developed at Ircam since 4 years now. So just to give a bit of context, it's something related to Nexus Hub that Jesse presented this morning. There is also Rhizome by Sébastien Picmal. I don't know if it's still something that is maintained or not. It has been initially developed by Sebastian Robaskiewicz and Norbert Schnell in, yeah, you have the date. And since then we had two versions in, yeah, two major revisions. So I will just go through some free work that we have been developed last year almost. And I will focus on the user, which is not the end user, but the user that is creating in his system. So an artist, a researcher, composer, more the expert user that will use the system at the end. So that's it. So first example is a set of small application based on movement and developed using sensors on smartphones. And the control interface to develop this kind of application is just like that. So it's quite complex. You can really create a lot of project, switch project during the application is running and stuff like that. The second one is it will be weird because it's a conference. So I just cut the sound because it was too weird to have a video of a conference in a conference. But you will recognize someone in the room. But it shows the one of the controller that has been developed, where you can see on the right all the clients that are loading sound files, and there's been a lot of work made with Garth to create an application that give you just the important information you need while you are performing, but also that allows the composer to just compose, actually. So it's a trade-off to give some openness to the system. Last example, and some publicity for Garth, if you are here on Saturday, there will be a concert. And last application is it is more an installation that has been made for the Centre Georges Pompidou that is based on Raspberry Pis that you can see on the bottom. So it's basically each agent is a Raspberry Pi connected to a speaker, and they were hidden in the wall of the place, and with a proximity sensor to trigger some global behavior of the system. Soon there will be an event. So that's basically what is triggered when somebody can close. Okay. And you can see on the bottom that's a screenshot of the application where we can see the state of every agent in real time and take control over each agent and trigger some possibilities of the system to see how it behaves and have an idea of how it will behave at the end In real life, okay. One of the main aspects we've seen is that it's really important to maintain an agency and flow for this kind of expert user, because these tasks are mainly exploratory. You would never know what you will do at the end, and the developer can take a lot of decision and reduce the possibilities of the user that wants to do something, actually. So I guess it has something to do with cybernetics, and it's about control and monitoring. And for that, we need to create a current state of the whole application. So thus, we have implemented new things. First, the scope of the framework has been reduced a lot to allow people to learn it, because the Surface API was really big and really hard to remember. So now it should be easier to learn. There's no more views, and the new thing is the state management system that allows to, I will do a short demo at the end. So basically, that's it. Distributed system centralized over a Node.js server. The new thing is the fact that we can integrate Node.js client, and that's basically the same as writing a browser client. The initialization process is the same for everybody, so yeah, it's not really interesting. And the state management system, so it's inspired by the Flux pattern that probably many of you knows through libraries such as Redux or Vuex or something like that. But it had to be adapted to take into account this distributed aspect. So it's extended to so we have the state in the client. Some events are triggered and change the state, but the state is always synchronized with the server side, and then we can do the rendering. So we have a consistent thing. We keep the consistency this way. And for that, we have designed a small protocol, I would say, because one of the things is, if we want to, the interesting aspect to keep this state maintained over at least in the server, is that any client can attach to the state of another client and take control over it really easily. And yeah, so as you can see, I don't have my mouse. So we have a player that can create its own state, and some controller just attach to this state and can act on the state exactly as if it was the creator of the state. Yeah, and that's an example. So everything is based on small schemas. And that's it. Okay, and let's go to the example. So for example, yeah. So here on the left, I have the controller. So I have some global parameters of the application, such as a master volume or mute thing. And I can create several players. And this way, I don't know, maybe it's small, maybe better. So we can see that everyone is keeping the master volume quite well, but we can also take control over one particular client. There should be some. Yeah, I don't know. So So no sound. Oh, because there's no. But I could do the same with another one. That's it. And main idea, if we look to the code, is just to this part of the code. And so we have the state manager, and we can observe every state that is created by anyone on the system and choose if a player creates a state, I want to know about its state and do whatever I need to do with that. And another thing that is quite funny is that it allows to, and there's absolutely no server-side code. There's server-side code, but it's hidden. And we can change a state, and going through, there's a new slider for cutoff frequency, and so it allows to test new things really easily and rapidly, and being in a rapid iteration loop. Okay. And thanks.
Thank you. Are there any questions?
Hey.
Hey.
So we have this conversation about how Soundworks now that I'm not at Ircam anymore, but we can do this publicly. Yes, what I saw there on the screen was there was two-player one. I mean, there were 4 clients when you had the web browser open. That was four clients.
Yeah, you can put 10 if you want, and you have 10.
I see. But they. So on the left side, I have a controller where you can evoke the state of each client as you like. I didn't understand can you explain once more what's going on there?
Okay, so in this, I could normally, for an end user, you have one client, and that's all. But from the controller, I can take control over it. This thing is just to not open 10 windows when you have to do something. It's all in the same window, and it's kind of practical. So you just wait because it has to open socket. But then you have 10 clients. It allows to, just simplifying the development process. Actually.
Any other questions?
Thank you for your talk. So as far as I understood this, it's sort of like a way to share actions on some kind of state across instances of a program?
The whole framework is made to simplify the development of this kind of applications. That's all. Take doing stuff that you don't want to do each time, writing a WebSocket server, blah, blah, blah. And the new thing is mainly that kind of shared state that is completely circular. Yeah.
Cool. Thank you.
Welcome.
Okay, you? Okay.
Hey, I'm here. So I saw that you have a lot of primitives for distributed audio experiences. Do you also plan to work on providing primitives for visual parts of these experiences?
We have primitives that at Ircam that Norbert developed, and but the main idea was to remove every notion of rendering, because there was this view system and some audio primitive was in the framework before, and it makes everything complicated because somebody wants to use React and other wants to use Vue. I don't know, the next famous JavaScript framework to do something. I don't know, and why not? And and it simplifies also the maintenance of the framework. To just, if people do what you want, it's not my problem.
Okay. One last question.
Thank you, Benjamin. Just a couple of questions then. So is it possible then to dynamically change the player interface during performance? Like could I send new interfaces at different points during performance then?
This example is really made to be simple and just show the some basic feature that I think we need in this kind of distributed thing. But after it's an application, if you want to change the GUI.
And you could do that dynamically rather than just having the same fixed interface for the entire performance.
No, you have to prepare it at some point.
Okay.
That's probably a future work because it would be really nice. Would be able to modify the schema dynamically, because then you can just maybe create your logic from a client, and it opens up a lot of stuff. Then I think I'm not sure.
So a follow-on to that then would be, at the moment, if I understand it correctly, all the players can also control other player interfaces. Is that correct?
If you want, yes.
Yeah, so could you group those, or is there some way that the controller could constrain the access to everybody else from the client?
That's the development. In this case, for example, the clients they don't know the player on the right don't know each other. They know the global state, but they don't know each other. They have no idea of each other. Only the controller knows the other. Well.
Okay. Thank you very much.